Okay, everyone, welcome to our first session of dynamics. Apparently, this electricity plug is not working, but we will see as far as we can go today. Then I think we can figure it out next time. I did double check this, by the way, before coming to this class. It was working. Anyways, so I hope you're doing good. Again, for dynamics, our strategy will be pretty much the same as to 6. Attendance is not mandatory, but at the end of the day, there are no comms that your exams will be face to face. We will have a midterm 1, midterm 2, and we will have a final exam. All 3 of them will be 30, 30, and 30. Then you will have graded homework assignments of 10%. Again, graded homework, we will have a very lenient policy. It's entirely for your own learning. As long as you submit within the due date, you will get generous points. Any questions we have? Any concerns? Yes, no? Okay, then on that note, let's quickly start. We have dynamics. So in your statics classes, your instructors have already taught you summation of forces is equal to 0 and summation of moments is equal to 0. And that meant that the acceleration alpha angular acceleration 0. Now in dynamics, things will be more fancy. We will have summation of forces will not be equal to 0, and or summation of moments will not be equal to 0. Summation of forces and summation of moments might also not be equal to 0. So either one of them is not 0 or both of them is not equal to 0. There is a pen. So for example, let us have a demo. No pen. Something to throw. No, I need something to throw actually. It's not for. So for example, that's fine. This will go there. Should I throw? Okay. So for example, summation of forces is not equal to 0, right? And one more time, summation of moments is not equal to 0, right? And right, so summation of forces is not equal to 0, summation of moments is not equal to 0, because this fellow was rotating. It had an alpha. Let's say alpha. Let's not get into that. It was a constant angular velocity problem. So if it had an alpha and at the same time it was accelerating, so you see, that's one case. So you have, thanks, I will return it. Summation of force is not equal to 0, summation of moments is not equal to 0, or and. Either way, you have a nice fancy dynamics problem. And right now everything is 0. Okay, that's good. We are on the right path. Just keep looking at the battery. I'm pretty sure we will be done at 40 minutes, but anyways. Okay, so as we proceed in this class, we will talk about kinematics first. Kinematics means we will be talking about position, velocity, and acceleration like your physics 1. And we will be, in the initial 3 weeks probably, focus on point objects. Okay. Now, what is that? In very easy English, when size is not of importance to me. So I have a car that is going at 30 kilometers per hour and I'm talking all fancy things about that car. That car has 4 wheels. It has 3 people inside it. The mass is distributed in it. I'm not getting into that. I'm just taking car as a chunk that is just moving. That's a point object. The moment I tell you that the front tire is at this distance from the rear tire, the person sitting forward is 80 kilograms, the sizes are important, their locations are important, then that's not a simple point object problem. Okay. So in the initial 3 weeks, life will be super nice for us. Point objects, we will be happy. Then we will continue this nice discussion with kinetics. Now, kinetics means that I have found the position, velocity, and acceleration. You know what? Now let's talk about the forces. Okay. And then this is where the semester really takes an interesting turn when we get into rigid body motion. Now, that doesn't mean that the initial part of the semester we are talking about fluids or something that is not rigid. Rigid body motion specifically means what I just told you a few seconds back. A car has one person on the front, one on the back. It has 4 tires. The mass is distributed in a certain way. That means you are talking about now the sizes and locations of those objects. It's more like a real object. That's a rigid body motion. Now you are not considering the whole car as one chunk, rigid body motion. And in rigid body motion, again, kinetics. In rigid body motion, we will talk about simple translation. Like this is a simple object. It's just translating an object that is just rotating. So it's a tire. Hang on. No. Tire that is rotating. But if I have a tire, let's say I push it, now it's rotating, but it's also translating. That's not easy. That's now a complicated problem. So we will have a general motion as well. And we will talk about translation and rotation. Okay. Okay. That's a very quick recap idea of how this semester we will be going. Good. Right. And definitely throughout this semester, for those of you who are also taking 206, you will keep on comparing both the courses because both of them are so different that I also ask everyone which of the two they find more interesting. Okay. And usually it's the dynamics, by the way. Anyways, so let's go get into our first quick topic. It's more like your physics 1 refresher, rectilinear motion. Rectilinear means, yeah, straight line means 1 dimension, 1D. Simple 1D. Simple 1D. That's rectilinear motion. So where did the pen go? So let me talk about, let's talk about, that's a position. Okay, so first thing, very quickly, position. If I want to talk about position, I need to have a reference. So let me make the frame of reference or origin here at the corner of the room, let's say, wherever. So let me make the corner of the room, whatever. This is O. And let's say this is my 1. This is my 2. Okay. And we have, okay, let's put this arrow. That's my position vector. Now, what is a position vector? Position vector identifies or locates the position. Now, let's say I have another point. In fact, let me be a little careful in the color scheme. This is, let's say, location 1. Let's say this is location 2. And let's say, okay, now if I have to talk about the position of point 2, I want to make a position vector. So from where should I start? From where? Origin, yes. Whoever said that is correct. So because this one is easy to be confused about. we don't start from second. Origin is, so this is your S2. And of course, in rectilinear motion, it also makes sense that I make one side as positive and one side I can take as negative. Now, the point is here, the object is here at t1, the object is here at time t2. So just a quick remark, if anyone is interested in change in position delta S, then I think you already know S2 minus S1. That's easy. And you can call this as displacement. And another thing is that this delta S magnitude, we call it as distance, which is our magnitude. Okay, so far so good. And just one quick remark for those of you who are saying, what about delta S? So let's say we have another one that is S. So let's say this is a point 3, location 3, let's say. The object arrives here, time is t3. So what will be the position vector? You have to again draw an arrow from the origin very quickly, and boom, this is your S3. So delta S, if you again want to find, it can be, let's say between 3 and 2, you can say S3 minus S2. It's entirely up to you. But this time around, you might want to call it as 2. And this one, for example, you want to call it as 1. You have to just differentiate. So you can keep on playing this game. Now, let's quickly arrive at average velocity is equal to delta S by delta T. You already know it from physics 1. Another thing, let me quickly make it. Okay. You have, this one is your T1. This is your location 1. This is your location 2. And let's say the object is going in this path. Let's say this is your time. Let's say this is your position. And the object's position is going like this. Oh, let me make it a little more easy for me. Okay. And let's say the object like this. So if you want to talk about average velocity, it will be delta S by delta T. So average velocity will be like this. I hope it is visible on the screen. Let me know. It is. So your average velocity will be this fellow, the slope of this yellow line. So it will be V average equal to delta S by delta T. This is your point 1. This is your point 2. This is your T1. And this is your T2. This is your, no, it's not complete. This is your S1. This is your S2. So we can't care less what is happening between the points. As long as we know the position and time of this, we can talk about average velocity. That was easy. Now, if you want to talk about instantaneous velocity, it is, anyone who wants to tell us instantaneous velocity? Yes, yes, thank you. So it will be limit delta T approaches to 0. Thank you. Delta S by delta T. And your answer is correct, because once I do equal to, it will be ds by dt, as you just rightly said. Thank you. Okay, I'm not sure about this notation. Have you seen this notation before? This one? Anyone? You have? Everyone? Okay, great. So we will be using it time and again. Dot means derivative with respect to time. 2 dots mean second derivative. 3 dots, I highly doubt we are ever going to use it. But just remember the number of dots means I keep on taking the derivatives. Okay, and just for the sake of completeness, very quickly, let's say you are interested in talking about this instantaneous velocity, the slope here, okay, and the slope of this line is your, it will give you instantaneous velocity. So far, so good. Nothing fancy, right? Okay. Okay. Burke and Chan can also comment. Should I continue? 6, 5, 4, 3, 2, 1. Okay. Okay, so let me very quickly write V is ds by dt, as most of you already know. Okay, and average acceleration is equal to delta V by delta t. And again, let's talk about instantaneous acceleration. That will be limit delta t approaches 0. And we have AAVE, which is equal to, I think all of you can give it a try. Yes. Yeah, delta V by delta t, correct? Which is equal to, because of this, dV by dt. Yes, thank you. Which is equal to V dot. Just don't forget this one. And I'm in habit of putting a little circle. Always recognize I'm talking about derivative, which you can write as d over dt, ds by dt. Which is equal to s double dot. Life is good. Okay. Okay, so right now I think we are going at sonic speeds because it's your physics one. Now, just one quick remark, because now I think the foundation is set. Now I will actually talk about a little few things. Now, you already know this, done, and you already know this, done. First remark is, the first one is intuitive, the velocity. Acceleration is less intuitive. It's less intuitive, it's a little hard to understand. The velocity is more intuitive, more easy to grasp from a physical perspective. Even when we go into questions, you will have that feeling. Now, you have 3 cases that I will be talking about in this class very quickly. 1, 2, 3. Number 1 case, acceleration is a function of time. Second case is acceleration is a function of position. 3 is acceleration is a function of velocity. Now, acceleration, a combination of the 2 variables, I'm not getting into that. Right now, I'm talking about 3 very simple cases. Acceleration a function of time, acceleration as a function of position, and acceleration as a function of velocity. Practical examples are a little straightforward. So for example, I see a red signal. The moment I'm approaching that signal, I know I have to put, I have to stop. So that's why I keep putting my foot on the brake. So let's say if I write it in a mathematical form, my acceleration may be a function of position. And similarly, when the signal goes green and boom, I really want to get out of that place. Acceleration as a function of velocity is more like a drag force problem. When vehicles or anything go through wind or fluid, we know we have a drag force. The higher the velocity of the vehicle through fluid, let's say, the higher will be the drag force on it. So acceleration is a function of drag, which is a function of velocity. So these are three different cases that we will be talking about. So let me, instead of going to the next slide, let me talk about case one. So acceleration is equal to dv by dt. Okay. Now, when I say case one, that means, let's say in a problem statement, I'm the one who is telling you A is equal to 3t power 2. I have given you that acceleration is equal to 3 multiplied by t power 2. That means it's a case one I have given you. Once I have given you, you just quickly write A equal to dv by dt, because now you have to figure out the velocity changes, right? So v1 to v2 dv equal to integral t1 to t2 a dt, and you have, so you can perform the integral. Let's do it on the left hand side. What will happen? Integral 1 dv will be v, then v1. Okay, I'm just going very step by step, which is equal to, okay, I think here I will stop, t1 to t2 a dt, right? Okay, let me now remove this and I will put v2 minus v1. Okay. Okay, let me remove it. I will put a delta v. So everyone is with us right now. Okay. Now, in case few of you are wondering, why did you remove the arrows from here? Yeah, for my own convenience. Right now, I'm talking about very simple problems. I'm not getting into the vector part of it. So I'm saying it's a simple problem for now. So I just removed the vectors and made my life easy. So if you want, I can also remove for now vector from here. So this means delta v is equal to area under, yes, area. No, acceleration is a function of time. So I cannot pull it out of the integral. Area under AT curve. So for those of you who are saying, what on earth is happening here? For making an example, let's say somebody gave me acceleration curve. It was like that. Done. All I have to do is, this is, let's say, my T1. Let's say this point is my T2. Please follow me. Let's say I make this like this, then I make like this. So this will give me the change in velocity. Straightforward, right? Once we do an example, I think it will be more clear. In fact, just so that there are no confusions, everyone is with us. Let's say I have another curve like this. So let's say this is again my T1. Let's say this is my T2. Then I will just, oh, it's very hard for me. Let me make a simple line. And let's say a line, another line like this. Now all you have to do is like this. So this is delta V greater than 0. Quickly. And this is delta V less than 0. Again, delta V is area under the AT curve. Now, I know you will be like, well, this is so straightforward. Why are you even telling us? If I have to find the delta V. I know there is a formula A equal to dV by dt. What's even the point of writing it? Yeah, there is a point of writing it because the moment problems become complicated, 6, 5, 4, 3, 2, 1, the moment it becomes complicated. So for example, I give you acceleration equal to 3 times position. 3 times position. This is not second, this is position. Let's go back. Acceleration is equal to 3 times position. Okay. Instead of A, I will write 3 times position. Stop. Can you integrate 3 multiplied by S dt? I don't think so, because you cannot proceed. There is a time sitting here and there is a position sitting here. The only way you can proceed is if there is acceleration as a function of time. So you will remain stuck. You cannot do anything. So you have to develop different methods to crack them. So I will write, let's say acceleration is a function of position, but the problem is that the formula is the same dv by dt. What I can do? Well, I can say dt is equal to dv by a, and I know that velocity is ds by dt. My whole objective will be to remove the time. And I will have dt equal to ds by v. So now all you have to do is, this is your 1, this is your 2. So you compare them and you have dv by a equal to ds by v. So you will have a ds equal to v dv. So if you have acceleration as a function of position, this fellow will come to our rescue. So this a is s double dot, and this v is s dot, and this dv is ds dot. Oh, sorry, hang on. What did I write? Yeah, it's correct. So for those of you who are saying, how can this help us? Well, my objective was to find the change in velocity, right? So let's see if it can help us. So v dv equal to ads. Let's perform the integration from v1 to v2. That's your v dv. Now I have absolutely no problems because acceleration is already a function of position. So I don't have any issues. Integrate this, anyone? V square over 2. I will put a line with a v1 with a v2, which is equal to area under the AS curve. Should we stop? No, we will do a v2 square over 2 minus v1 square over 2, which is equal to area under the AS curve. So in fact, we can write it one more time, 1 over 2 delta v square, which is equal to area under the AS curve. So let me just make an example and we can finish our today's class. So let's say this is our AS. This is our curve. Let's say this is our T1. Let's say this is our T2. This is AS. So anyone who wants to tell us what will be the area under the curve? Well, it will be 1 over 2 delta V square. By the way, just one quick remark. 1 over 2 delta V square. 1 over 2 V square. Does it ring any bells? 1 over 2. I don't have space, by the way. 1 over 2 V square. Sorry? Kinetic, right? So 1 over 2 V square is kinetic energy per unit mass. But that's fine. And just one more remark. It's a little extra thing, but I'm afraid some of you might end up making this mistake. Just remember that this delta V square is equal to V2 square minus V1 square. In an exam setting, please don't write it as delta V square. It happens. Delta V is V2 minus, don't write it as V2 minus V1 whole square. Okay, let's do a quick example. In fact, you will all do that example. Burke Chan, and we have Tashni Chan. Do you have any questions, please? You have questions? Oh, yes. Okay, we have a response. No, thank you. Okay, everyone. I'm making an example. Okay, so let's do it. So the example is something like this. We have, again, some in science lab. Okay, and this is how much time do we have for the class, by the way? 15 minutes, right? Okay, so let's see if our laptop will. Oh, no, this is just deceptive. No way it will hold for 42 minutes. Let's see. So we have this negative plate and we have a positive charge plate. Just remember one thing. The initial two classes you might find slow, then we will go at sonic speeds. This is 200 millimeter. So this is position. Okay, let's say some scientist has put, there is an electron right through the center. And of course, there is this electric field. And this distance is, I think it's pretty clear, 100 millimeter. Sorry? No, electron, 100 millimeter. The question says that you have to find the V2. And I have put S from here. The question says, find V2 of electron if the acceleration is 4s. Now, what does that mean? It's a function of position, and the farther you are away from the negative plate, the more it picks the acceleration. Okay. Now, is there anything that is missing? Yeah, you just put the electron right through the center of the plate, right? You hold the stopwatch. You hold the stopwatch, right? If you hold the stopwatch, you can say that the position right now is 100 millimeter. And since you have the stopwatch, T1 is 0. Okay. 0. You just put it. Yeah, it's a good remark, by the way. Okay, do it. Is there any information? Yeah, it's straightforward. So you have to find the velocity just as it arrives the positive plate. probably I can do in parallel. So how to start the solution? V2 square is equal to integral. Okay, yeah, this is the tricky part. S1 to S2. That's 100. That's 200. I'm not sure if everyone picked that one, because this is your origin, right? Because S is defined from here. Do you remember in the first slide? Again, I pointed to the corner, that's your origin. So it's easy to get confused. If S is defined from here, my S1 is 100, my S2 is 100 plus 100, 200. And here you will write 4S ds, and the problem pretty much finishes here. V1 square is a goner. I have 1 over 2 V2 square equals to an integral of 100 to a 200 mm, and boom, it's gone. 4S ds. So I get 1 over 2 V2 square equal to any questions? We have 4S square over 2. So I will put a bar with a 100 millimeter with a 200. So I think you can use a calculator, and this time you really need to help me. I don't know the answer. How much? 60,000? No. 60,000 millimeter per whatever is not correct. Right. So it is, I will tell you, V2 comes out to be 0.346 meters per second. You can use a calculator. I also have a calculator. Double check. That's correct.
But 60,000 was for the right hand side only.
Ah.
And you will multiply.
Okay.
You will take that.
I needed the answer.
The square root of 0.4. Sir, is the answer 340?
Yes, correct. Correct. And just so that all of you have a physical understanding of acceleration. This is acceleration, this is position. And our question was like this. This was 4, by the way. It's not required. I'm just intentionally making it. Just to add another layer to make the problem interesting, why don't you find the delta t? Can you do it?
Yes.
Okay, give it a shot. Everyone do it. Okay, so I will definitely help you in this one because it's not straightforward. Okay, let me just write it down for you. 1 over 2, no, integral t1 to t2 dt is equal to integral, this is not straightforward, s1 to s2 ds by v, right? So I hope you realize this is velocity equal to rate of change of position with respect to time, right? I just wrote it in this way. Now you cannot proceed right now. Why? Because you want to find time, right? The problem is on the right hand side, you have a ds. Okay, that's fine. There is a v. Now you need a v in the form of s for you to have an integral. So that's very hard. It's not straightforward. So now my energy will be spent in me finding the velocity of that particle as a function of position, so I can put it in this integral. So it's a little lengthy analytical process. So this is how you will proceed. You will write 1 over 2 v2 square that I already wrote on the previous slide equal to integral. I have to go from 100 millimeter to 0. But this time around, I will not put 0.2 s. Yes, because I need to have the v in the form of position. So I will put a general variable s, and the rest is straightforward, apart from one integration, by the way. So it will be equal to 4 by 2 s square, the integral. I will put a 0.1 meter and with an s. So why don't you please tell me what will be v? One more second. Instead of v2, you can remove this, okay? Because you do not have. Just put it a general v. So tell me the expression. Some expression, fancy expression. It will be 4 over 2 is 2. S has bracket. There will be s square from here minus 0.1. Yes, 0.1 square, correct? Bracket. There is a v square, right? So I think there will be a 1 by 2. Okay.
Also, we have 1.5 in left side.
Yes. So I took it here.
But we have 4 divided by 2. We will get 2, and we will multiply with 2, we will get 4, I guess.
Yeah, 4.
Really?
In front of the s. The under root of 4 is 2, so it comes outside, and then the root goes on the function.
Yes. Yes. He is right. So I think I skipped steps. That's why it's confusing. So let me explain. This 2 will go to the right. 2 4s are 8. 8 over 2, 4. 4s square. 4s square under root will give me. So 2 will be pulled down. You do step by step, you will get 2 bracket s square minus 0.1 square bracket 1 by 2. Now that you have got this, let's do the final part and let's call it a day. Oh, come on. This is equal to integral s1 to s2. Let me use a different color. I will have a ds. So I will be giving you a homework for this one, by the way, divided by 2s square minus 0.1 square 1 by 2.
Can't we just, we know the distance, we know the velocity, can't we just get the time over there?
Okay, I will answer your question. I will go back. We have the distance, we have the velocity.
Yeah. Can't we just find the time?
From here,
Yeah.
acceleration is not constant. If acceleration is constant, the life is very easy. Then we have lots and lots of formulas from our physics 1, like 2as equal to v2 square minus v1 square. That is for constant acceleration. A is 1, A is 7, A is 7.5, A is 9.5. Similarly, I had another formula s equal to v I subscript it plus half at square, if you remember. Again, A is constant. A is 1, A is 2.7, A is minus 3, A is 17.5. Here, A is a function of position itself. If A is a function of position, A is a function of time, A is not a constant, life is not easy. Okay. But that is a very important question, by the way. You have to make a remark in your notes. That's excellent. Because if acceleration is constant, life is easy. Okay, everyone. You got your first homework assignment. You You have to figure it out, please. So the answer is 0.658. And I'm sure you're, oh, okay, this is seconds. Your next question is, will in exam you will have such a tough integration? No. Answer is no. But for a homework kind of a scenario, why don't you all just try to have a look into it? You're definitely not covering such integrations here. That's not needed. But
Is this going to be graded?
no.
No.
This one is more like look into it. You will have two kinds of homeworks as well. One will be a graded homework. It will always have graded written with it. Graded homework 1, graded homework 2. I might also send you some ungraded homework that is for your own review. Okay, everyone. Okay, any questions, concerns, reservations? Okay, let us ask our online students. Burke Chan, Tashin Chan. If you want to unmute the mic, please participate. You're always welcome. Okay, here is save. Save. Okay, no questions, no clear. Thank you. Okay, and